Welcome to Pre-Calculus. Today we will investigate writing and graphing inverses of quadratic and square root functions, focusing on restricting the domain of the quadratic so that the inverse square root is a function. We'll take a look at two examples. The first is a quadratic, the second is a square root function. So our first example here gives us the instructions first to write a square root inverse function for the quadratic function. So we'll do that first. Once we have the inverse equation, we'll graph the original and the inverse on this coordinate plane with the identity line y equals x. And then we have to decide how should we limit or restrict the domain of the quadratic so that the inverse is a function. Well, let's start with that first task of writing the inverse. Our steps are the same as the inverse writing we've used for linear functions and for cubic and quintic polynomials. We'll begin by calling f of x y just to decrease the clutter there. So we'll say that this function in terms of the original is y equals negative parentheses x plus 3 close parentheses squared plus 2. And then recall to write the inverse, I'm going to switch the domain and the range, which in terms of the equation are my x and my y. So my inverse will be recorded as x equals negative parentheses y plus 3 close parentheses squared plus 2. And with that switch of the x and the y, the domain and the range, we've got our inverse. Now, in order to make that graphable, I need now to solve for y. So let's do that now. I've got multiple things to move that are surrounding y right now. So I see I've got a plus 2 on the outside. I've got a negative sign in front of the squared parentheses group. I've got the square and I've got the 3. So if I think about how many terms I need to reconcile, it's really 4 items I need to deal with. Well, let's start with the constant on the outside, this plus 2. So I'm going to subtract 2 as an initial step so that my next step will read x minus 2 equals negative parentheses y plus 3 close parentheses squared. The next item that I need to cancel on the right is the negative sign. And we can think that that is really a negative 1. So there's really 2 options here. I could either multiply the right side or divide by negative 1. So just to make for easy calculation, I'm going to multiply by negative 1. And that's going to cancel. So I see negative 1 times negative 1 is going to result in positive 1. And then I need to also incorporate that multiplication by negative 1 on the left side here. So that'll distribute through my binomial, and our next step will be negative x plus 2. So we just see the sign switch on the left side. Equals positive parentheses y plus 3 close parentheses squared. My next operation to cancel here on the right is the square. So I'm going to apply the square root. And because those are inverse operations, they do cancel each other out on the right. And that throws the square root over that left side. One thing I need to observe is that algebraically, that operation is plus or minus the quantity negative x plus 2. And that we have to reconcile in a moment to make sure that we've got an inverse that is actually a function. So I'm going to put plus minus, but in a moment when we go to graph, we're going to have to decide plus or minus. We'll write them both right now. So it's plus or minus square root of negative x plus 2. On the right side, the square has now been canceled, so I just have y plus 3. And my last step will be to subtract 3. And that'll appear on the left outside the radical. So now all that I've got left on that far side is y, and I'm going to switch the function or the equation around. Remember, equations are commutative. I can switch the order. So that's y equals plus or minus square root negative x plus 2, and that's on the inside of the radical. On the outside is minus 3. My last step to indicate that this is an inverse of the original f of x, I'm going to put that inverse notation. So remember, that's the power of negative 1. We read that the inverse of f of x is plus or minus square root negative x plus 2, and then on the outside minus 3. And I'm going to box that. And that completes our first task. We've written the inverse equation for our original quadratic. Our next task is to graph the original along with the inverse here on the same coordinate plane. So to do so, I'm going to create our table. And because we're looking at two functions, the original and the inverse, we'll give 3 columns here. So the first column on the left is for x. And let's put here negative 2 through positive 2. And again, we choose those because it's a central slice of the graph kind of centered around the origin. And we can always incorporate more values there if we need to. We do choose those domain values. So our first output column here, I'm going to put the original. So negative parentheses x plus 3 squared plus 2. And then in our far right column, I'll put the inverse, which is plus or minus square root negative x plus 2 minus 3. So what I'd like to do is I'd like to get a table of values, and what we'll do is we'll use the Desmos graphing calculator to do so. So let's head over to Desmos and make sure that we write those down first. So I'm recording those two equations, the original quadratic and the inverse. And we'll graph these on the graphing calculator. So we'll put in the original first. F of x equals, there's the negative out front, open parentheses x plus 3, close parentheses, and we're going to square that, and then minus 3. I'm getting my functions confused. Let me back up. Plus 2. There we go. So there's the original. So we can see it's a parabola that opens towards negative infinity. It's a downward opening parabola. And we'll graph the inverse. Now, because it's plus or minus, I am going to input the inverse in 2 different entry lines. So I'll use g of x just to help Desmos out here, equals. So this will be the positive square root. Remember, square roots in our keypad in that first group on the left. So this is negative x plus 2 on the inside, and then to the right on the outside, minus 3. I'm also going to put in the negative version. So h of x equals negative. Again, I'll choose square root from the keypad, negative x plus 2 minus 3. And that gives us a view of the inverse. I'm also going to type in the y equals x identity line. So recall we put that as kind of a confirmation that we have a good inverse pair. So as I look at the graph here on Desmos, I see those characteristic traits of 2 inverses. They are intersecting each other here in 2 places. Both of them are down in quadrant 3, but they're both on the identity line. And then I also see a reflection across the identity. If I were to fold the original quadratic over that purple identity line, the curve would land exactly on the inverse, these blue and green. Now, one issue that we have to reconcile with is the question, is this set of square root functions, which really represent one inverse, is it a function? So what I'm going to do is I'm going to suppress for just a moment the original and the identity and just look at that inverse and recall to decide if a given relation is a function. On a graph, we run the vertical line test. And what we're looking for is that as that vertical line passes through the function or the relation, it should only intersect one point. If it intersects more than one point, we have to say it fails the vertical line test. It's a good relation, but it's not a function. So let's just place a vertical line that will pass through this graph. So I see that -4 is an x value that's defined on this curve. So I'm going to write x equals -4. And when I look at how that vertical line intersects my inverse, I see it definitely intersects here on the blue part of the curve at -4, -0.551, and below at -4, -5.449. So I see a vertical line intersecting what I've calculated as the inverse twice, which means that this is not a function. So what I need to do in order to ensure that that inverse is a function is I need to select either the positive or the negative half. So what I will do is I will just without loss of generality, I'm going to select the positive version. So I'm going to suppress the negative side. And what I want to do then is, so at that point I can see that that is now a function. The vertical line at -4 is passing through only one point on that square root. What I need to do at this time is reintroduce the original, and I need to limit its domain so that when I do this inverse writing, the square root is a function. So I need to limit the domain of the original. The way I decide how to limit the domain is really based on the vertex of the quadratic. So I am going to find the vertex there. It's at -3. The y value is 2. So I see that the side that will give me the inverse that's here in blue is the right half of the parabola. So the way I want to restrict its domain is so that the x values are greater than or equal to -3. Again, I'm getting the -3 from the x value of the vertex. So to do so, I'm going to go into that entry line for that original parabola, and I'm going to hit Shift curly bracket, x is, and then from the keypad greater than or equal to -3. And I'm going to close that curly bracket. And at that point, I'm going to take away the vertical line, replace the identity line, and I see that I have a very good pair of inverses now. Both the original with its restricted domain and the positive half of the square root are functions. And so at this time, what I'm ready to do is get a table. In fact, I'm going to generate two tables. So for the original with the restricted domain, I'm going to write that table. So notice it doesn't include that vertex. So you do want to include the vertex x value in your list of domain values. So recall that was -3. I'll back up to -4. So -3 is at 2, -4, just to see how our domain has been restricted. -4 is undefined for the original now. So I'm going to record those values down. At -4, it's undefined. At -3, it has the y value of 2. -2 has the y value of 1. -1 has the y value of -2, and 0 has the y value of -7. If I record 1 and 2, those are off my graph. 1 is -14, 2 is -23. So I'll record them, but I won't be able to represent them well on my graph. Let's get a table also for the positive square root. And that's the one that we've left active there on the graph. So I'm going to hit convert to table. And I'm going to record these values. So I'll start, we can back to -4 just so that we're matching with the original quadratics domain. Keep in mind at -4, our square root function is defined. So at -4, its value is -0.55. -3 is at -0.76. -2 is at -1. And -1, I'm sorry, is -1.27. 0 is at -1.59. 1 is at -2, and 2 is at -3. I do want to go one step further just to see what's happening at 3. So on my square root function, 3 is undefined. So that's what I need from Desmos. I'm going to head back to the note screen to graph this pair of functions along with the identity line. So I'm going to modify this table just to indicate how we have added other values. So I'll just clear those out. And we again backed to -4, and then included -3, -2, -1, 0, 1, 2, and 3. So let's fill in our values. So again, the way I limited this original was that x is greater than or equal to -3. Made the value at -4 undefined. -3 was the vertex, it was at 2. -2 was at +1. -1 was at -2. 0, -7, 1, -14. So here's the ungraphable ones. And I didn't even calculate at 3, and that's okay, because again, that will be very far off our screen on the lower side of quadrant 3. Now let's fill in for our inverse. So at -4, it was defined as -0.55. At -3, -0.76, -2, -1. At -1, it was -1.27. 0, -1.59. 1, -2, 2, -3, and at 3, that was past the defined x values for my square root function, so that's undefined. So we're ready to graph this pair of inverse functions. So again, I'm going to start with the parabola at -3, 2. And that's its vertex. At -2, it has the value of +1. -3, I'm sorry, 0 is headed at -7. And then past there, we really can't graph, but I can sketch that curve in now. So there, notice it's half of a quadratic. It's not the full quadratic. Again, we restricted the domain so that it would be able to generate an inverse that was a function. We'll graph that inverse now. So at -4, that's at -0.55. At -3, it has the value of -0.76. -2 has the value of -1. -1 has the value of -1.27. 0 has the value of -1.59. +1 has the value of -2. and positive 2 has the value of negative 3. So that's going to be the vertex of the square root function. So now I'm going to graph this one. And at that point, what I'm ready to place is my identity line. So remember, the identity line starts at the origin and then has a slope of 1. So I can mark those points from corner to corner and then place the identity line. And then we can include the reverse direction as well. So then what we're looking for, the reason we include the identity line, it's really the definition of an inverse. The composition of an inverse with the original should land on the identity. And the way we're seeing that is this intersection of all three curves at one point. So definitely that shows that intersection of the original and the inverse on the identity. I'm going to mark that because that's one of the key features graphically that confirm we've got a good inverse pair. Intersection on the line y equals x, the identity line. The other key feature, recall, is the reflection of the function across the identity line should land exactly on the inverse. And I see that if I folded that red one across the purple line, it would land directly on the blue inverse. Similarly, if I folded the blue inverse over the identity, it would land back on the original. And that completes our tasks here. Again, to recap, we wrote the equation of the inverse by switching x and y, solving for y, and that gave us this inverse equation. And then we created tables for both the original and the inverse by restricting the domain of the original from its x value of the vertex. And what that did for us is it ensured that the inverse square root was a function and not just a relation. And then we graphed here the original and the inverse on the same coordinate plane. Let's take a look at a second example where we start not with a quadratic, but with a square root function. So here we've got number 7, and you can see that the instructions are very similar. Again, we're trying to write the inverse for this, in this case, a square root function. So I got the directions slightly reversed here, but we are writing a quadratic. So I'm going to fix it here. We're writing a quadratic inverse function for this square root function. The other directions are identical. We want to graph both the original and its inverse on this coordinate plane along with the identity line. And then we do need to limit the domain of the quadratic inverse so that the square root is a function. Again, with this one, we're starting with the square root. So we'll follow those same instructions by switching the x and the y. But first, what I should do, I'm going to call f of x here. So our function here is f of x equals negative square root negative x plus 4 on the outside minus 1. So I'm going to call that, instead of f of x, y. The rationale behind that is just to reduce the clutter, especially as I go to switch x and y. So we'll make that change right away. Instead of y, I'm going to write x equals negative square root negative, instead of x, y plus 4 minus 1. And in truth, that does create the inverse. I've swapped my domain and my range. To get it in a graphable form, I need to solve for y. So like we saw with that first inverse writing, we've got multiple parts to move and to cancel on the right. So I'm underlining negative 1 on the outside plus 4 on the inside, the negative in front of y, the square root, and the negative on the outside of the square root. So if I count, there's really, again, multiple things, in this case 5 either values or operations to reverse. Where should we start? A good place to start is always a constant added or subtracted. That's the easiest to cancel here. So I'm going to cancel that -1 by adding 1 on the right, and that shows up also on the left. Now I've got x plus 1 equals the negative square root of negative y plus 4. So then the next thing to cancel is any coefficient or sign out here in front of the radical. So I got a negative there. And the way I'm going to cancel that is by multiplying by -1. And I'll repeat that multiplication on the left. So on the right, that cancels. And I'm going to also distribute the -1 through that left binomial, so that what I get next is negative x minus 1 equals positive square root negative y plus 4. I now want to cancel the square root. Put parentheses, and recall the inverse operation for square root is the square. So on the right side, that will cancel. On the left side, I put parentheses around negative x minus 1 and apply the square. And you can see how that's created a quadratic now. On the right side, that equals negative y plus 4. So then two things to reconcile on the right. I'm going to cancel plus 4 by subtracting 4. And where that appears on the left is on the outside of that parentheses group. So that now I've got negative x minus 1 squared minus 4 on the right side equals negative y. The last thing to reconcile here is that negative on the y. So same strategy we used for the previous negative. I'm going to multiply by -1. It will cancel. And then on the far side, I got to put a -1. And where that will distribute is in front of the parentheses group. So it won't enter the parentheses. It'll land in front, and then also to the -4. And we're ready to write the inverse. So I'm going to switch the order of the equation so that y is on the left. Y equals negative parentheses, negative x minus 1 squared plus 4. And that is a graphable quadratic inverse. To indicate it is the inverse, I'm going to use the inverse notation. So inverse of f of x equals negative parentheses negative x minus 1 close parentheses squared plus 4. And that I'm going to box. That completes my first task. I've written the inverse equation. So now we're ready to graph. I'm going to create our table. Just like we did on that first example, I want to include columns for each function here. So we'll give our x values, and again, we'll just kind of make an initial guess, -2, -1, 0, 1, and 2. We can always revise that. And then the original, in this case, is the square root function, which is negative square root negative x plus 4 on the outside -1. And then the inverse quadratic, which is negative parentheses negative x minus 1 squared plus 4. And I'm keeping in mind that I do need to limit this domain somehow. So we'll be on the lookout as we head to Desmos for how I want to limit that domain so that we have a pair of inverses that are in fact both of them functions. Let's head over and get a table. So I'm going to record down my two functions, the square root and the quadratic. And we'll go back to Desmos to get our tables. Once we get there, we'll clear out this old function. One thing that we'll leave is the identity line. And we're ready to input our two new functions. So I'll leave the identity line. Again, that's the check graphically for whether or not I've got a good inverse pair. So here's our original. F of x equals negative square root again in the keypad in that first group, and under the radical negative x plus 4 on the right side minus 1. Let's also input the inverse. So for Desmos, I'll use the next letter, g of x equals negative, close parentheses, negative 1, negative x minus 1, close parentheses, and then to the power of 2 plus 4. So I can see initially that I've got that situation again where definitely the quadratic's a function. It would pass the vertical line test. And we can see, especially if I remove those other two. So it's good. That in itself is a function. But I do want to, again, reconcile it so that it corresponds with the square root part that we have pictured. So if I put up the identity line, I notice that the place where they intersect is with the original, that lower side of a square root, and the left side of the quadratic. So the way I want to limit the quadratic for this example is, again, from the vertex. So I can find that just by clicking at the absolute maximum there on the graph, and that's the point negative 1, 4. So when I think about which half of the quadratic I want, the left half, x is less than negative 1, or the right half, x is greater, I want to select the half that's intersecting my original square root on the identity, and that's the left half. So I'm going to come and restrict the domain on the quadratic here, curly bracket, and I want the left half. So x is less than or equal to, and I believe that that was negative 1. And I need to make sure that I don't say less than and type greater than. So I got to switch that around. And that gives me a true pair of inverse functions. And I can see that twofold confirmation that they're good inverses. They're intersecting here at the identity. And they also show a symmetry. If I were to fold the original across that identity line, it would land on the square root inverse. Similarly, down below, if I folded the original square root over, it would hit the quadratic inverse. So with that restriction complete, I'm ready to get tables for both of these functions. And I'm going to select for the radical first. Now I notice that we can take those x values out to 2, but the vertex on the graph for the square root is at 4. So I do want to extend past to 4. And we can see that that's the case. 5 is too far. That's undefined. So my table will graph from negative 2 through positive 5. And those values are, so at negative 2, the square root's negative 3.45. Negative 1, it's negative 3.24. 0 is the value negative 3. 1 is the value negative 2.73. 2 is at negative 2.41. 3 is at negative 2. And then the vertex 4 is at negative 1. 5 undefined. We include that value just to say that that is undefined. I'm also going to create a table for the quadratic inverse. And remember, we've limited our domain. So what I'm seeing there is that all these values past negative 1 don't have defined outputs. So I can kind of record for 0 and onward in the table undefined, all the way through 5. In fact, that one's undefined all the way to positive infinity, past -1. So to make sure that I include more points on my quadratic, I'm going to head back to -4. And I'm going to record those values. So I do need to adjust and include to -4 on the table. So it's going to be an extended list of domain values. So at -4, this quadratic has a point at -5. At -3 is its x-intercept, or at 0. -2 is 3, and the vertex -1 is at 4. Before I head back to to our graph, we're here on Desmos, I'm going to also include to -4 for the square root, just so we have those values. So -3 had the output -3.65, -4 was -3.83. And that gives us what we need from the graphing calculator. Let's finalize our graph on the notes screen. Let's include those values that we had added to our domain. So -3, -4 on the left side, and then through 5 on the right side. And we'll fill in now for our function. So the square root function had these outputs: -4, -3.83, -3, -3.65, -2, -3.45, -1, -3.24, 0, -3, 1, -2.73, 2 is -2.41, 3 is -2, 4, -1, and then 5 we'd included just to see that's the kind of the cutoff past the x value of 4, that square root function is undefined. Now for our quadratic function, and we limited it to x is less than or equal to -1. Again, that's the x value of the vertex. So for -4, that had the value -5. -3 was at 0. -2 is at 3. -1 is at 4. Everything past that for this quadratic, based on our restriction, is undefined. So I'm going to put undefined and then just U for all these other outputs. It's undefined all the way to positive infinity. So now we can graph our two functions. We'll start with that square root. So -4, -3.83, -3, -3.65, -2, -3.45, -1, -3.24, 0 is at -3 itself, 1's at -2.73, 2 is at -2.41, -3 is at -2, and 4 is at -1. So there's my square root function. And notice it is the lower half of that full. I have kind of a ghost upper half that I'm not including, so that is a function. Now we'll graph our quadratic inverse: -4, -5, -3, 0, -2, 3, and -1, 4. And that's our cutoff. So again, we had only graphed half of that quadratic so that we ensured that it's a good inverse to the original square root. Now I'm going to place the identity line so it is corner to corner through the origin. Slope of 1. And the two hallmark features we can clearly see here. We've got the intersection of the original and the inverse on the identity line. So it intersects on the identity. And we also see that telltale reflection across the identity. If I were to fold the quadratic over the identity, it would land on the original square root. And on the other side, if I folded the original square root over the identity, it would land exactly on the quadratic inverse. And that completes that task. So again, just to recap, we started by writing the inverse equation by switching x and y, which is switching domain and range. We solved for y, and that gave us our inverse equation. And then we graphed and by creating a table on Desmos, restricting the domain of the quadratic so that it is a true inverse to the original square root. And then once we had our table, we graphed it here on our coordinate plane with the identity line to confirm that that's a good pair of inverses. We're looking for the intersection on the identity line, as well as a reflection of those curves across the identity. So thank you for joining for this investigation of writing inverses of quadratics and square roots. I'm going to let you work on your questions. Thanks for joining. See you soon.